So Kyle, you were picked first. Sorry. So, what do I have to do to find the minimum?
I just graphed it,
Okay. And what'd you do?
and then I just calculated where the minimum is.
You did the second calculate.
Yeah.
Min. What's the calculus way to do that, right? What do we do?
You did the derivative of the function.
So you can do the derivative on the calculator. Or we could do product rule first times the derivative of the second plus second times the derivative of the first. And then graph that and find where the zeros are. From 0 to 2 pi, what'd you guys get? Stephen, did you get any numbers? No, not yet. And I don't remember what they are. But whatever, on the calculations, Cameron, did you get any yet? Okay. The Delta Math, that was the last assignment of last semester. I need to get you guys a little polished up on using the calculator. I hate using the calculator because if you typed anything wrong, you're just screwed. So I don't wanna dock you for not being able to type or that your batteries died. I'd rather be that you didn't go to math. And I can't tell with the calculator. So anyway, process of finding maximums and minimums, do the derivative of the thing you want to maximize or minimize. Find all the places that it's 0 or undefined, it's not undefined anywhere here. And then test on the number line. It'll be a maximum when it goes from, the derivative goes from positive to negative, and it'll be a minimum when it goes from negative to positive. But another thing they'll do is part D. Right, but do not evaluate an expression for the position of x of t at any time. So, okay. Rowan? What do I do?
You would just integrate VFD and then plug in the point of the result to find C.
So integrate V of t. From where to where?
0 to 2 pi. No, just in general. Integrate
How do I say in general?
0 to t.
0 to t. Is that gonna tell me the position of the particle? I'm missing something. Yeah. All you have to say plus 12. You need to tell me, where did you start and then you added this much change? And, okay, I will get more and more into AP expects this. This is not enough. So that I wrote x of 0 to imply, like, to be clear, what's the one spot that I know, add the amount of change. If there's anything symbolic in your answer, like, we can leave the V of t or we could write it out, but if there's anything, like, you need to say, I know what that one is. They want the number there. If you say f of 2, they want what f of 2 is rather than f. Right? So that's kind of old stuff. what we're doing today, we are starting areas between curves. Homework is day 80, it's on the sheet that you just got. And I believe on there it says EOO, that stands for every other odd. So like 1, 5, 9, those of you who do all odds, penalties on you for not being able to read. Okay, we will see how much we get through. We will probably get here today, and we'll pick up with integrating with respect to Y tomorrow. You guys hate that, you gotta look at it sideways. We'll get over it. Okay. So, I wanna find the area between two curves. I just wanna find the fish belly. Anyone got any suggestions?
Find the integral of f, and you subtract the integral of g.
You said find the integral of f and subtract the integral of g. Think so? Because f is all of this, and if we cut out or subtract g, we get just the fish belly. Yeah. So, exactly what he said, and there's the shortcut. We're gonna do the top curve minus the bottom curve integrated over this space. Simple enough? So that gives us a positive y value, top minus the bottom. So we get a positive length times our positive dx width. Whereas integrating, we could get negative answers. If you're getting negative area, that's wrong. Means you've either got your bounds backwards or you did the setup wrong. So this is just to remind you that integration was all areas of rectangles, again. So the height is the highest one minus the lowest one times dx. And what happens when we go to a negative thing? Does f of x minus g of x still give us a valid length? Is that still gonna work, or do I have to do something special because g of x went below? Absolute value? Well, let's say this y value is 7 and this y value is -3. What is the length of the stick? 10. Does that work with 7 minus -3? Does that give me 10? So it doesn't matter, so this will always work? Yes, it will. So just showing you, you don't have to be worried about it. Comes out in the math, we love that. It's always the top minus the bottom, even if the bottom's negative. Actually, even if the top is negative. If both of these were below, this is -7 and this is -10. -7 minus -10 will give us a length of +3. So it's all good? Okay. So this is that concept written out in math, grossness. And it says the one function needs to always be over the other. Sebastian, what would happen if they trade places over time?
Well, if they're trading places, then it's not like clear which function is always over.
Yeah?
But if you're going from A to B, then in that case, isn't G just over, so you just integrate from there?
Okay. What do you guys think if I wanted the integral from C to B, the area trapped between the curves? Amelia?
Do C to A and then add it to A to B.
C to A, what minus what?
F of X minus G of X. And then add the integral from A to B, G of X minus G of X.
So, if they trade places, yeah. And when they say area between the curves, like the little fish belly one that we did a minute ago, or showed a minute ago, and they gave you specific bounds, use their specific bounds. If they don't give specific bounds and say, what's the area between the curves, it needs to be pitched shut like a balloon. This, not pitched shut, not area between the curves, it's unbounded, they go on forever. This, I had to change the picture. Those are pitched shut. I see it as like finding the amount of air caught between them. And if it's open-ended, the air doesn't stay in, it's not caught. Okay, so, first thing, draw this. Cosine, sine, and x equals 0. Okay, I used to ask the question like this: find the area of the region between y equals cosine x, which is the green line, y equals sine x, the blue one, and x equals 0, the y-axis, the orange line. So what's the area trapped? What I just said, well, it's this, or it's this. It needs to be the area that touches all three colors. Some students want to include this stuff. That doesn't hit the x-axis, it's not included. So, valid question, which side do I want? The left side of the bubble or the right side of the bubble? So I needed to add that. So which side am I looking at? The right, for x greater than 0, so I want, ooh, cool. So I want this. Okay, what's the top curve, Max?
Top curve should be cosine x.
Evan, what's the bottom curve? top minus bottom. What are the bounds, Naomi?
Would it be 0 to pi over 4?
Okay, so how do we get pi over 4? Well, often they'll tell you, but this one, they're like, no, y'all gotta know. Where does cosine equal sign? Most of you know pi over 4. If you don't, you can do the taboo thing that we tell you to never do in pre-calc. Divide by the trig function. Cosine's not allowed to be 0. Well, you know what, it's not 0 there, so I'm good. So where is tangent 1? Oh, unit circle, pi over 4 and 3 pi over 4, that's not, I don't want the one outside that. So yeah. So do the integration, what do you get? What is the area between the curves? Adam, what'd you get?
You don't need a calculator.
What's the integral of cosine? Negative sign? Positive sign? Okay, what's the integral of negative sign? Positive cosine. Once we integrate, the stick moves to the right in a straight line, which means now evaluate. So Alice, sine of pi over 4? Root 2 over 2. Sadie, cosine of pi over 4?
Root 2 over 2.
And here's the rookie mistake. You guys see the 0 and you just blow it off everything when you plug in 0 is 0, but that's not true. Cameron's like, nah, man. Sine of 0 is 0, but what is cosine of 0? 1. Rookie mistake if you just said, oh, I don't need to plug in the 0. Root 2 over 2 plus root 2 over 2 is root 2. Okay. So root 2 minus 1, not need a calculator, roar. Good morning, Ben. How you dealing with calculus first up? You're gonna get blinded by the sunlight?
Yeah, not nice.
Well, you know, we have methods of adjusting that. Okay. And when you guys get an answer, talk to each other. Put your end answer on the whiteboards. 2. So I see an answer of negative 5/3. Does anyone else have an answer yet? 9/2. First of all, we can't get negative area because we're doing top minus bottom, we're getting, maybe it's positive 5/3. Any other answers? This is 9 divided by 3.
3.
What's 8 minus 3?
5.
What's 5 minus a half?
9 halves.
So I got a 4.5, 32/3. Any other? Okay, plugging in the 2.
I plugged in 1, so I'm gonna put
2 squared over 2 is 2,
1. That's out there.
minus 8/3 plus 4. Minus negative 1 squared became positive 1. Negative 1 cubed is still negative, but then we got it added. And then negative 2. You can't do this yet, but on the AP exam, if that's your last thing, you can leave that mess. You may not leave that mess on my test. I will be like, no, y'all gotta clean that up. Well, 2 plus 4 is 6, and then distributing the negative, subtracting a half, subtracting a third, and adding 2. Roman tells me this is negative 3, so 8 minus 3 is 5, 5 minus a half is 4 halves, which is 9 halves, so I agree with these two. Okay. Questions? Okay, this one you need a calculator. So, try that one. Really, I want to see, do you know how to use the calculator? And we can probably do calculator tricks. Can anyone remind us how to find the intersection points on a calculator? Second trace, okay, second trace, which is calculate. Number 5, which is intersect. Okay, so it's blinking and it says, is this the first curve? It's got a question mark. You need to say, yeah, that's one of the lines. And then, is this the second curve? Yeah. And if I say guess, different calculators do different things. I moved it a little bit off the axis. It will, depends on your calculator. It might take the closest one, or it may take the first one on the right. For me, that's the same thing. Okay, and do you guys remember how to take that value? What do I do?
Second quit,
Second quit,
then you can press X,
and now if I hit X, that is my intersection point.
and you can store it.
Store it in, I don't know, A. I don't know about you, but I type wrong all the time. I see the numbers backwards, whatever. I mess things up. I use this a lot. Okay, so here's my graph, and what was that number again? 1 point.
1765.
1.765?
1765.
There's a 1 in
Yeah, 1.17.
1.1765. Okay. So, do I need to calculate the other side, or do I know something? They're symmetric, so. Okay. Eddie, how do I set up? Okay.
Now that you have your 2 points, you could do, the integral from negative 1.1765 to positive 1.1765. And then you would do cosine of x minus the whole thing of y squared minus 1 on dx.
Okay, she said the whole thing, meaning don't forget the parentheses. I was like, oh yeah, because I was gonna forget. If you forget the parentheses, that -1 becomes a -1 instead of a +1 when we distribute the negative. Okay. So on my calculator, I'm gonna say, where's the integrate button? Math. I don't see anything. It is off the screen. It's number 9. And those of you with the really nice 84s, you don't have to deal with this, but oh well, I do. Cosine minus x squared, and then subtracting a negative because I didn't put the parentheses in, +1. So that's my function. Integrating that with respect to x from negative a to positive a. And actually, I'm going to mess it up. Bummer. So I got an error, and when your calculator gives you the option to go to, please hit it. Say go to where the problem is. Oh, I typed in the subtraction symbol rather than the negative sign, and it's blinking on it. So I do that, and it's hard to see that one because you're like, it's a subtraction, it's what I want. And it says no. So there's an answer, 3.1138. You could leave that as 3.114 or 3.113. Please keep at least 3 decimals. It's shocking to me that some of you still round to 1 or 2 and say it's okay. It's not. All right. Is there another thing I could have done? Another way I could have set this up? There was something said about the symmetry.
I guess you could have done it from, integrated from a 0 to 1.17, and then multiply that by 2.
Yeah. I could have integrated from 0 to A and doubled it. When you do these by hand, I highly recommend that you do this, because you're gonna get something, if you do it by hand, you're gonna get 7 minus -7 or whatever if you do it this way, versus if you start at the 0, you're gonna get 2 times 7, which is what you wanted. Subtracting the negative hurts you every time. So be careful of that. But did everyone succeed with feeding the calculator into submission? No issues? Ray doesn't have a calculator. Okay, so you all know how to use the calculator. Not lying. Okay. All right, well, 1, 2, 3, or 4. Adrian, 1, 2, 3, or 4? It's always like, oh, Russian roulette. Try number 4. And I blame Pete. Okay. So there's communication issues. I asked what were the intersection points. This is I had 4 exit cards that I used in the past, and I stressed pretty clearly I wanted the coordinate, because what we're doing tomorrow, we're gonna need the Y values. So I made a big deal to them that I wanted coordinates. So you guys did correctly find the X values of -1 and 1. I wrote it down as a coordinate because I could change things. So let's see. Something like that. Finding the area between them is 4/3, if anyone got that far. Tomorrow, we're gonna do areas this way. rectangles. What is the width of the rectangle when drawn that way? Evan, what is it? They're dy. So when it's dx, all the things are in x values, right? So I have, the height is some blah, blah, blah in terms of x, and the width is some blah, blah, blah in terms of x. And there's the smaller x value and higher x value. So tomorrow, we're gonna do y value stuff. Really fun. I usually hate it for a little while and then you get flexible. Yeah.